Hi students, good morning. In AI, Unit 1, 2 and 3 are completed. Now today, I will start the unit number 4, Symbolic Reasoning under Uncertainty. Okay. In this unit 4, we are learn basics, what is reasoning, then different approaches for reasoning, then introduction to non-monotonic reasoning, logics for non-monotonic reasoning. Okay. So today I will start the basic introduction. What is reasoning? Reasoning is the act of deriving a conclusion from certain properties using a given methodology. Here the definition of reasoning is given. We can conclude something, okay, and for the conclusion we can use different properties, different facts, and we are giving some mathematics rules or equation. So this whole process is known as reasoning. And reasoning is a process of thinking. We are thinking about some rules or for some math or process, okay? And reasoning is logically arguing. We are argument but not orally. We can use some logic, and reasoning is drawing inference. We are drawing something, okay? Suppose you can make some project and you can prove something. One algorithm is already execute, and you can use that algorithm and implement something. So it is the logically prove, and we can say that it is the reasoning process. Okay. When a system is required to do something that it has not been explicitly told how to do, now we can consider some system, okay, and system requiring something, some data, some information, some algorithm, and here we can't use the explicitly, means we can't use direct, okay, but we can use indirect, that method, and it must reason, and we can give the reason why we can use the system, why we can use that data, okay, and it must figure out what it needs to know from what it already know, and then we can figure, means we can find out the needs, what are the basic requirements, okay, and from that basic requirements what details we learn or we are know, okay, we are familiar with something, some requirements, so we can separate that requirements. So this is the basic reason for the reasoning, and many types of reasoning have been identified and recognized, but many questions regarding their logical and computational properties still remain controversial. Means here different types of reasoning are given, and then we can separate all types, okay, and we can find out the questions and solution for that particular question. Okay, and the popular methods for reasoning include abduction, induction, model based. Here some basic methods are given. Popular methods of reasoning. Okay, first is abduction, second is induction, third is model based, fourth is explanation, and fifth is confirmation. Okay, here some basic or popular methods of reasonings are given. We are not familiar with all methods, okay, but here we can consider only name of the methods. Then all of them are intimately related to problems of belief revision. Means we can find out the problem solution and we can compare the problem with the above problem. Okay, then we can find out the theory deployment, knowledge absorption, discovery and learning. Here we can use different terms and find out the problem solution. Then first logical reasoning is given. In this logical reasoning, first a basic explanation is given, and then some sentences are given for logical reasoning. Logic is a language for reasoning. We all are know what is logic. Okay, when we are making some program, then we can use the logic for that program. It is a collection of rules called logic argument, and we can use the collection of rules means one or more rules, and they are known as logic arguments, and we use when doing logical reasoning, and then we can say that we are using logical reasoning. Now logic reasoning is the process of drawing conclusion from premises using rules of inference. Means we can conclude, we can find out the ending or finishing process, and premises means assumptions. We can assume something and then we can find out the result. In maths you can first assume like x is equal to 10, then you put the x value into some equation and find out the result. So here we can use that concept in the logic reasoning. And the study of logic is divided into formal and informal logic. Now we can divide the logic into two different paths. First is formal and second is informal. Okay, now the formal logic is sometimes called symbolic logic. You can remember this sentence. Formal logic is sometimes called symbolic logic. Means we can use different symbols in this type of logic. Then symbolic logic is the study of symbolic abstraction that capture the formal features of logical inference by a formal system. Now we can study symbolic constraints, what are the symbols, what are the features, okay, and then we can make some system. It is known as formal system and it is consist of two components. Which two components? formal language and inference rules. Okay. The formal system has axioms. What is axioms? Axioms is a sentence that is always true within the system. We can take some sentences and that sentences is always right. Okay, and we can say that that sentences is known as axioms. Okay, and we can use the axioms into formal system. Now sentences are derived using the system's axioms, and rule of derivations are known as theorems. In maths we learn the theorem. Okay, we can find out some rules and its derivation, and we can say that theorem. The logical reasoning is of our concern in AI. In AI we can use the logical reasoning. Okay, so this is the basic detail about logical reasoning. Now different approaches are given. Approaches to reasoning. There are 3 different approaches to reasoning under uncertainties. First is symbolic reasoning. Second is statistical reasoning, and third is fuzzy logic. Okay, so we are use the 3 approaches for reasoning. First is symbolic reasoning. In this reasoning, first the basic introduction is given, then the detail are given. The basic for intelligent mathematical software is the integration of the power of symbolic mathematical tools with the suitable proof technology. Here we can use the basic. What the basic detail? Mathematical software. Okay, for power of symbolic mathematical tools, and here we can use the proof technology. Means we can take something and we can prove something. Okay, so in the mathematical reasoning, enjoy a property called monotonicity. Means similarity. We can find out the similarity between the different symbol or sentences, and if a conclusion follows from given premises like ABC, then it is also follow from any large set of premises. And here we can say that we can find out the conclusion, and for the conclusion we can use some rules. Okay, and in the rule we are make the different set of attributes, and as long as the original premises ABC are included, and when we can add some external attribute but our basic attribute are same, and we can use different rules. Okay, human reasoning is not monotonic. Human reasoning. Okay, but human is not machine, so we are not saying anything about the human, so human is not monotonic. Now people arrive to conclusions only tentatively based on partial or incomplete information. Now people can make the conclusion. Conclusion for tentatively means temporarily. Sometimes we are find out the temporary solutions. Okay, so that situation we can use the data, suppose partial data or incomplete information, then reserve the right to retract those conclusions, and we can find out the conclusion, and we can derive the new facts, or we can learn the new facts. Such reasoning is non-monotonic precisely because the set of accepted conclusions have become smaller when the set of premises is expanded. Now we can learn the new facts, okay? And in reasoning, not all reasoning are monotonic, some are not non-monotonic, okay? So then we can accept the conclusion, okay, and we can find out the different set of expanded or different set of attributes. Now second is formal logic. The formal logic is the study of inference with purely formal content. In the formal logic, we can use the pure formal content for equation where content is made explicit. Here we can use some content and it is explicit. Here we can take some example for propositional logic and predicate logic. These two are the examples of formal logic. So in this both logic we can use the study of formal content, means we can study something and we can find out the result, okay. So here the definition is given for formal logic and its example is given. In example we can take two different logics. First is propositional logic and second is predicate logic. Now the logical arguments are a set of rules for manipulating symbols. Now we can use the logical arguments and we can find out the different set of rules, and rules are manipulating symbols. In rules we can use different symbols, okay, and then we can make some logical arguments. Now the rules are of two types, okay. We can take two different rules. First is syntax rule and second is inference rule, okay. So in the first rule, syntax rule, we can say how to build meaningful expressions. We can make some sentences and find out the particular meaning for each expression or each sentence, okay. This is our first rule. It is known as syntax rules. Second, inference rule. In this rule we can say how to obtain true formulas from other true formulas, means we can separate the true formula, which formulas are right. We can separate that formulas and we can use the other true formulas, okay. In this inference rule, okay. So in logical argument we can use the two different rules. First is syntax rule and second is inference rule. In maths you can follow some syntax, okay. So here you can build meaningful expressions, and in inference rule we can use the true formulas from the other true formulas, okay. Now logic also needs semantics. We can use the logic, then we can use the semantics, okay, which says how to assign meaning to expression, and here we can find out the expressions, okay. and meaning for that expression. So this is the basic about logics and formal logic. Now next topic is uncertainty in reasoning. Okay, uncertainty means unexpected things which are happening in the reasoning. So first the basic introduction is given. The world is an uncertain place. Often the knowledge is imperfect, which causes uncertainty. Here we can take the example of whole world, okay, and we can find out the many places which are uncertain in the whole world. So we can't have the knowledge about all places. So here the different causes are generated in the uncertainty. Okay, therefore the reasoning is happening, and here we can operate the uncertainty. Means we can take something and find out the results, our opinion. Okay, it is known as uncertainty. Now AI system must have ability to reason under conditions of uncertainty. In AI, here we can take different uncertainties and desired action. First is incompleteness of knowledge. When we can't have enough knowledge, then compensate for lack of knowledge. Then what is our action? We can find out the all details. Okay. Second is inconsistency of knowledge. Then desired action is resolve ambiguities and contradictions. When we can't have the complete data, then we can find out the proper knowledge, and when we can't have the right data, then we can find out the similarities. Okay, and changing knowledge. When we can change the knowledge, then update the knowledge base over time. We can update the knowledge between the time limit. Okay, so this is the uncertainty in reasoning. Now next is monotonic reasoning. The definition of monotonic reasoning is once the conclusion is taken, then it will remain the same even if we add some other information to existing information in our knowledge base. Now in the monotonic reasoning, we can find out the conclusion. Okay, and from that conclusion we can say that our data are same, or we can add something, some information into that knowledge data. Okay, so this is the definition of monotonic reasoning. Now some another sentences are given. A reasoning process that moves in one direction only. We can move some process, okay, in some particular direction and find out the results. Next is the number of facts in the knowledge base is always increasing. We can use some facts and we can increase the number of facts, okay, and we can find out the results, and the conclusions derived are valid deductions and they remain so. Now we can find out the conclusion. Our conclusion is right or wrong, and our process is true or false. So this is the monotonic reasoning basic introduction. Now a monotonic logic cannot handle some details which are not handled by the monotonic reasoning. First is reasoning by default, because consequences may be derived only because of lack of evidence of the contrary. Means sometimes we have not proper knowledge about some data, so that time we can derive some sequence and we can find out the reasoning. Which reasoning? By default means basic reasoning. Okay. Second is abductive reasoning. In this reasoning, it is not handled by monotonic reasoning because consequences are only deduced as most likely explanation. Means for some systems explanations are used and some system can't have explanation, so here we can't use that systems, so it is known as abductive reasoning. And third is belief revision. Belief revision is not handled by monotonic logic because new knowledge may contradict old beliefs. Means when we can generate the new knowledge, then we can use the old knowledge. Okay, but here the belief is more important because some users can't believe the new rules or regulations. Okay, so this is not handled by the monotonic logic. So this is the basic introduction about reasoning. Now I revised the today video lecture topics. Today I will start the AI unit number 4, and in this unit 4 I will start the first theory, what is reasoning, its basic introduction, its definition is completed. Then logical reasoning is start. In this topic the basic definition and some explanations are given about the logical reasoning. Then different approaches are given for reasoning. Here we can use the 3 different approaches. First is symbolic reasoning, second is statistical reasoning, and third is fuzzy logic reasoning. So I will start the first, symbolic reasoning. In this reasoning I will explain the basic detail. Okay, and we can take one example of mathematics reasoning. And human reasoning is not monotonic. Then we can start the formal logic, its definition, its example are given. Propositional logic and predicate logic are example of formal logic, and 2 rules are used in formal logic. First is syntax rule and second is inference rule. Then second topic is uncertainty in reasoning. In this topic some uncertainties are given and desired actions are given. Then I will give the definition of monotonic reasoning. And a monotonic logic cannot handle some data, so that data are listed out. Okay, so today I will start the unit 4 and its basic introduction, what is monotonic reasoning, and some basic definitions are completed. Now in the next video lecture I will start the next topic, introduction to non-monotonic reasoning, and second topic is logics for non-monotonic reasoning. Okay, thank you.